Hello, everyone. This is a recap session in Road to AGI series. Over the past few months, we've been working on solving ARC benchmark or try to get the better results with the ARC benchmark that we've been able to achieve some promising and very interesting results. And it feels incredible to see our approach making meaningful progress. Our project, Nucleoid, aka Nuke, is based on Neuro-Symbolic AI. We're going to talk about what that is, but introduce a novel twist intermediate language as a universal bridge between neural networks and symbolic system. The intermediate language plays a critical role in the combining two paradigms. While working on the ARC AGI, we found the Nuke language helps neural networks to abstract patterns, which is eventually used in the symbolic system. Surprisingly, LLMs behave near deterministic with the intermediate language. Before diving into our approach, ARC benchmark is unlike other AI benchmarks out there measure skills. They design puzzle questions. It looks very easy for humans, but AIs are quite struggling. It intentionally avoids tasks solvable by brute force statistical techniques or large-scale data training. In the ARC benchmark, we were able to get very promising early numbers that we used large llama 3.1, and we only trained with the three outside examples that we were able to get much better results than O1 and Gemini. As a matter of fact, we're almost able to answer correctly, but fail at the very last subtask. Just a side note, we use LLMs without prompt engineering, means just the pattern recognition. We'll get more details in the next recap session. Neuro-Symbolic AI combines the pattern recognition capabilities of neural networks with the logical reasoning and structured knowledge of symbolic AI. Neuro-Symbolic AI also aligns with the concepts from the famous book of Thinking Fast and Slow, explaining the AI should have two systems. It says the system 1 is for fast instinctive, and system 2 should be more logical. It's more cognitive science definition, but for computer science, system 1 is about the pattern and system 2 knowledge graph and reasoning. So if we apply this into Neuro-Symbolic AI, neural networks are system 1, symbolic is system 2. Let's put the system 1 and system 2 in actions. Let's say if something looks like a duck, swims like a duck, and quacks like a duck, then it's a duck. This is a duck test. Simply, it's system 1 at work. We've seen the ducks probably thousands or millions of times throughout our lives, which forms well-defined patterns in our cognition. When we come across something resembling a duck, human cognition does not trigger system 2 at all, because identifying the object as a duck is automatic and intuitive. Our brains rely on mental schema. Even the individual part of the duck, such as wings, bill, a webbed feet, are matched to their associated labels in the scope of the system 1. Again, we won't be surprised if we see the duck in the lake because we also have enough labeled patterns to make the call. But in this case, as our experiences typically associate the ducks with the natural settings, it's quite uncommon to see a duck in the urban environment at night. This unfamiliarity triggers System 2 to take over, engaging the more deliberate reasoning. So System 2 is now responsible for reasoning. A city is being dangerous after dark and the duck is in the city, duck may not be safe. Stay tuned for Recap 2 in Road to AGI series, and so long.